All right. I've got so many things that I want to talk about. I've been writing down all these things and I've been like coming up with these ideas because recently I've been really into physics and quantum physics and all that stuff. And it just kind of fascinates me that, after all these years, we still don't really have a good idea. And now that I dug into it, we haven't made any significant leaps in understanding for like half a century or something like that. To me, that's just crazy that progress like kind of halted, and we're at this point where like we don't really know which direction to take it because everything we want to do is like either so tiny or like so hard to do, like we just don't have the equipment for it. Um, but I think that that's interesting. That like I don't know, we're still kind of like we have a theory that works pretty darn well, but we haven't. It's not finished yet. I don't know. I think that like a common thing is we look back at science and there's like I don't remember who it is, but like a physics teacher like told someone like don't pursue physics because it's just about done, right? And then I can't think who it is, but it came up a couple of times while I was like going through it. And then that person ended up like discovering like a big thing that like changed our understanding, and I'm totally spacing on it, but um, I think that that's kind of where we're at right now, where it's like, oh, don't worry, like we just about have we have the standard model, it's just about done, and I'm not so sure. um, so I've been really, really interested in this. I've been putting a lot of time towards thinking about this stuff and like just watching as many YouTube videos as I can about people talking about the subjects. And I know that like I'm not like reading any like crazy like research papers and stuff like that. Like I'm not that invested. But as of right now, I'm just trying to get the general concepts to know which directions I want to pursue further if I want to actually develop a theory. Because I'm not a physicist, but physics always did fascinate me. I took one of my favorite classes, honestly, was a physics class. I wasn't very good at the math part, but just the theory and the concepts that the math led to, it was just always so interesting to watch unfold, and what those numbers meant. Like just like the specific numbers have such a key role in how our world works, and if they were different, like we may not be here. And it's so crazy to think that like things are just kind of working this way because they do. And that's about as far as our understanding is, and honestly I don't think our understanding is ever going to get past that. They work this way because they do, I think is going to be the end all be all statement. And at one point we'll have to accept that. I think that's my theory. Um, but I do think it's fun to think about this kind of stuff and learn about it. And so I'm like, you know what? Why not take my own shot at a theory of everything? So I've been writing stuff down and I've been thinking about stuff, and I'm like, oh, like maybe I might be onto something. I don't know. I haven't done any like proofs to be like, oh yes, this is 100% true. But I like the more stuff I watch and the more things I hear, like the more I'm like, yeah, well that aligns with what I'm kind of thinking. Like this kind of makes sense here. But the problem is that at this point, everything is so established. So certain things that I don't necessarily agree with, and I think might be wrong with our like it might be assumptions that are wrong, are such an ingrained part of it that we can't progress further because we've walked ourselves into a dead end. And we haven't realized we have to turn around yet, is what I think. But um, as I said, I don't know the complex math, but to me, at some level, I don't know if there necessarily should be that much complex math. And My goal is to simplify the standard model into an equation that is more is less random symbols in like if you look at the standard model and you don't understand mathematics, it is scary because it's all these like it's barely even numbers. It's like all these weird like symbols and stuff, and you're like, what's going on here? You have like you wouldn't even know where to start. And I feel like maybe it shouldn't be that. I don't know, because a part of me is kind of torn because I think my personal opinion is that things should be getting simpler. It should be easier to understand the deeper we go down because things are getting more and more fundamental. So it should be less and less complex, right? Doesn't that make sense? If we're heading towards the fundamental building blocks, shouldn't it get simpler? So that's my current thought process right now. But my problem is that only works if we're actually approaching the end of the line, because the problem, like I said when I started, is what we're running into is that things are so small we can barely observe it. Like we're not actually seeing these things ourselves. So we're basically just taking guesses in the dark based off of the data we collect. But we can't actually observe these things. And so we don't actually know how these interactions are taking place. And so we're kind of hitting a limit on what we can understand because we can only, see so far. Like we can only see so far out into the universe. We can only see so far down, into the microscopic. So we're at this kind of limit where, there's not a whole lot farther we can see with our current technology. And, my theory of it getting simpler and it should be easier and easier to understand is not necessarily true if, we're really only like, say, this like circle here is everything that we know now, but there's actually like this much more to go. Then no, I guess that doesn't really make sense. So I'm not certain about it, but I do think that on some level it should be getting easier to understand, even if we still have a long way to go. And so I'm unsure about the complexity that we're dealing with, and I think it also has to do with everyone sees physics, it's this complicated and difficult thing, so it has to be this complicated and difficult math. And I feel like there's almost a sort of maybe pride in being like, I understand physics, and I'm going to come up with the next complex and like intelligent thing to do, or like the next breakthrough in science. It's going to be this crazy complex equation that's going to refine everything. And I don't think a more complex explanation of things is the right way to go. And like string theory has very little proof going for it, but it is a common theory that, if you probably have heard about it at least. And there's not a whole lot of evidence backing it up, but it's this complex theory that, like, from what I didn't really watch a lot of videos on it because I'm not really interested in it. There's something about like needing 11 dimensions to make it work immediately turned me off of it, because I'm like, why do we need to add in so many dimensions to explain how our world works? I don't think we should be going up in complexity. I think we should be going back in complexity. So I just think I think that that's kind of part of our problem is we're expecting it to be this crazy complex situation, and going into how many I didn't really know much about I guess quantum physics and stuff and what has been discovered. So as I was going through these videos, I'm like, okay, there's the proton and the neutron, and then you find out inside the proton and the neutron there's quarks, and there's the up and the down and whatever, and then those actually have like two other different sizes, and they all have like antiparticles. So then like it turns out there's like over 50 particles or something like that. And I had no idea, but I think that it's kind of kind of ridiculous, because I was watching some of these videos and they're like, oh yeah, well, like, there's all of these things, but the most common ones are the up and down quark. They make up the majority of matter in the universe or whatever. And I'm like, if they make up the majority of the matter, why do we even care about those right now? Because back in the day, when they were trying to figure out what an atom was and how an atom works, they were like checking out like hydrogen and helium, like simple ones. I mean, maybe other people were doing other things, but like they were testing things like that on like the simpler atoms rather than on the most complex ones they could possibly find, because if you don't understand the basics, why would you understand what's going on with this complex stuff over here? So it's just kind of confusing to me that we're getting so caught up in all of these different charges. Let's not worry about finding more particles right now. Let's focus on figuring out how the particles we do have work. Because the more factors we bring into the equation, the harder it is to solve and understand what's going on. If you keep just adding puzzle pieces in, before you've got a couple, like if you keep just dumping puzzle pieces on your table and you haven't even like put a couple together yet, you've got nothing to go off of, So why not put a couple on, see if they fit? Okay, none of these fit. All right, we'll keep these over here. We'll keep bringing up pieces at a time and we'll see if they fit, right? Rather than just trying to pile more pieces on the table, eventually you got so many pieces you don't know where to start. So that's just how I kind of feel about it. But anyway, I'm going to now talk about my physics and what I think the future could be and what my current thoughts are right now. Because I've been watching all this stuff, like I said, and I haven't really sat down. I've done a couple like videos. I'm like trying to like draw it out and kind of think through it. But I feel like I just need to talk, because when I talk, I think more about it. I think better, and it helps me understand it. And then I can also potentially share my thoughts, and maybe it'll help someone else, spark an idea in their head, and they'll be like, that might be something, because there's certain, like I said, I don't know everything. I'm still trying to figure a lot of this out. I've been watching videos for like 2-3 weeks now, but I think there could be something in what I've been thinking here. At the very least, there's at least one thing that might be able to be taken away from all of these talks that I'm going to go through. But there's also the potential that I'm completely wrong. And if that's the case, I'm not a physicist. So, I don't know what I don't know. But I think that can also be a boon, because, like I said, getting so caught up in how things should be doesn't necessarily, lead to anything. Just because something should be some way doesn't mean that it is. And I think that not, having that rigorous background leaves my mind open to more possibilities. And what I've found is like some physicists, some of the biggest like breakthroughs like are just people trying things out, just thinking about stuff. Like some of Einstein's biggest breakthroughs, from what I've heard, like he mainly was kind of going through thought experiments, and by going through the thought experiments, he was coming to conclusions and stuff. And that's kind of what I'm doing, because I don't hate math, but I'd prefer not to use it if I don't have to, right? Like let's do the math once I have some ideas laid out. Is kind of is how I see it right now. But at some point you got to take a shot in the dark and see what happens. And if you miss, then you miss. All right, we'll just shoot again, I guess. But like, I think it's worth a shot. So I'm gonna do it because at the very least I think it'll be fun. So yeah. Peace out.